This is Mac 1105, section 1.6, about solving equations with rational exponents. This is actually section 1.6b in MATLAB. Now, all of these right here are examples of rational exponents. Let's just talk about what this means before we look at this right here. You have a rational exponent. It is equivalent to a radical, and the radical is this. The bottom of the fraction becomes the index of the radical. The x goes inside the radical, and the top number becomes the inside power. So the way I look at that 1/2, I think about when I go to my radical form, it is the top number goes to the inside, and the bottom number goes to the index. So inside over index. When you look at 1/2, one is on the inside, 2 is the index. 1/3, 1 goes on the inside, 3 is the index. 3/5, 3 is on the inside power, and 5 is the index. Now with square root, we don't write the index of 2. This is just understood to be square root of x equals 8. That would be my radical equation. We'll talk about solving that in a second. I just want to do some conversions right now. So x to the 1/3, the radical x is inside, the top power becomes the power inside, and the bottom is the index. So the radical equation would be the cube root of x equals 5, not 8, 5. This one, radical sign, put your x, the top number becomes the inside power, the bottom number is the index. Now I've heard people explain it this way. When you are converting the rational exponent to the radical, think about this 3/5, this number right here, toppling over. If it toppled over, the 3 would go as far away, and the 5 would be closer, which puts it in the index. So that's kind of a cute way to remember what it is. Now go back to this radical equation. If we're going to solve this, this is the square root. To solve this, we need to do the opposite, which is square both sides. So square root of x squared is x, 8 squared is 64, and that is my solution. So why did we square both sides right here? Because it was the opposite of square root. So take this over here. Remember we said these two problems were the same, they were just in different forms. So if we need to square both sides on this one to solve, we should also square both sides on this one to solve. Now, I just said that from the standpoint of what we did with the radicals. But the other reason we're doing this is this rule right here says to solve x to some fraction, raise both sides to the reciprocal power. The reciprocal of 1/2 is 2, or if you want to write 2 over 1. Now, why does that work when you're dealing with fractions? Well, when you raise a power to a power, exponent law like x squared raised to the 3rd power, we keep the base and multiply the exponents. That was your exponent law for multiplying. Same idea here. When I raise power to a power, I have the exponent 1/2 needs to be multiplied by the exponent 2 over 1. The 2's cancel, the 1's cancel, and all I get is 1. So this right here becomes x to the 1st equals 8 squared, which is 64. And of course, we don't write the x to the 1st, we just get the solution, x equals 64. So go back to radical form. This is the cube root of x. To undo that, we will cube both sides, because cubing is the opposite of cube root. That gives me x equals 125. Now, how does that apply over here? In terms of this problem, we raise both sides to the 3rd power, which is what we're doing. But the other reason we are doing it that way is because the rule tells me raise both sides to the reciprocal power. The reciprocal of 1 over 3 is 3 over 1, which you don't have to write the 3 over 1. You could just leave it as 3. But what happens with these powers is the 3's cancel, the 1's cancel, I get x, and then I just have to evaluate 5 to the 3rd power, which is 125. Same process down here, but in the radical form, there's more steps involved. I have to undo the 5th root, which would be raise it to the 5th power. And when I do that, I still have x cubed here. 2 to the 5th is 32. Now, to undo x to the 3rd power, I do the opposite, which is cube root of both sides. And of course, that does not come out even. I'm just going to stop there. I was just using that example to help us decide what to multiply by here. We will raise both sides to the 5/3 power. The 5's cancel, the 3's cancel, I just get x, and I would have to do 2 caret 5 divided by 3. and that does not come out even. It's going to be some weird decimal. And if that happens to you on MathLab, then what they want you to enter is just 2 to the 5/3. I have not told you the whole story yet. This next part here is very important. If m, which is your original top value, if that m is even, then you're going to get a plus or minus tacked onto your answer, and I'll show you why in a minute, but just right now look at the rule. If m is even, there's my m, it is even, I know my answer should have a plus or minus on it. So I just go right down to the bottom and put a plus or minus, and then I go back and do my work. Now what is the work? This is x to the 2/3. We need to raise it to the reciprocal power, which is 3/2. The 3's cancel, the 2's cancel, I just get x. And I can use my calculator to do 4 caret parentheses 3 divided by 2, which comes out to be 8. But I need to put it down here with my plus or minus. And the reason we get a plus or minus is that in the very beginning, with that power, the top power was even, therefore I'm going to get a plus or minus. Now here's the reason I get the plus or minus. Think about x to the 2/3 in its radical form. That is the cube root of x squared equals 4. That's what we just went over, how to change the rational exponent to radical form. The top power, the top number of the fraction becomes my inside power. The bottom of my fraction becomes my index. To undo this, I have to first start with the cube root part and raise both sides to the 3rd power. So the cube root of x squared cubed just gives me x squared, and 4 cubed is 64. Now to undo x squared, I do the opposite, which is square root. And what happens when you solve by taking the square root of both sides? You get a plus or minus. That's the reason we get a plus or minus if the top number is even. See, the top number being even means your inside power is even. And when you get down to this step, you're talking about an even power. And when you take the even root, you get the plus or minus. Now this one over here says if m is odd, my top number is odd, which it is in this case, 3, then there is no plus or minus to worry about. You just go about your business and do the problem. So x to the 3/2, I'm going to raise it to the reciprocal power, which is 2/3. The 2's cancel, the 3's cancel, I just get x. And I need to do 8 caret parentheses 2 divided by 3. And x comes out to be 4. No plus or minus was necessary because the original top, which was 3, is an odd number. So let's look at some more examples here. X to the 2/3 equals 9. The first thing you want to look for is the top of my fraction an even number? And the answer is yes. I'm going to put that plus or minus right there, right now. Otherwise, I'm going to forget it. So very simple. I just need to raise this to the reciprocal power, which is 3/2. So the 3's cancel, the 2's cancel. I just get the x all by itself, which is what I want. I need to evaluate 9 caret 3 divided by 2. And if your calculator doesn't have a caret, an actual upside down V, you have a button that either says y to the x or maybe x to the y. That's what you would use for your exponent. And when you type that in the calculator, that comes out to be 27. Put it right next to the plus or minus that we laid down in the beginning so we wouldn't forget it. So x equals plus or minus 27. Now this one has more stuff with it. It's not just my rational exponent. We need to isolate this x to the 3/4, so we need to do a couple little arithmetic maneuvers to get that x to the 3/4 alone. So add 6 to both sides, and then divide by 3. And finally, we have our rational exponent equation isolated. So x to the 3/4 equals 2. Take a look at the numerator. The numerator is an odd number, therefore I do not need a plus or minus, so I can just skip that part and go ahead to my raise it to the reciprocal power. So this is 4/3. This one is 4/3. 4's cancel, 3's cancel, I get x. Now something weird happens with this. If you do 2 caret parentheses 4 divided by 3, it doesn't come out even. It's some weird decimal. I didn't write it down. But if that happens, for MathLab, what they want you to actually enter is 2 to the 4/3. That's it. So the only time you're going to get a plain old number like this is if it comes out even on your calculator. So there is one in Math Lab that doesn't come out even, and that's all you have to enter for your answer. This is kind of like this idea. Remember this in solving by taking the square root? So to undo this and start to get that x alone, we took the square root of both sides. Same idea, we are going to raise this to the 3/2 power. But before I do that, let me take a look at that power. The original numerator of the fraction is even. Therefore, there will be a plus or minus involved in my answer. So when I apply the 3/2 power to both sides, that all cancels out. I get x plus 2. 4 raised to the 3/2 power is 8. But this is really where my plus or minus goes. I just went down a little too far with the plus or minus. Now you got to be careful here. We're going to get x alone, which means we're going to subtract 2 from both sides. And this is like how we did with the square root method and completing the square back in section 1.5. Squeeze in that -2 between the equal sign and the plus or minus. So this is -2 plus or minus 8. And we have to do, remember, high road and low road. -2 plus 8 and -2 minus 8 gives me 6 and -10 as solutions.